3.3a, collect and organize data. So a scatter plot, as a review, is a graphical representation of the relationship between two variables. Let me make this blue. Up here. Okay, so steps to creating a scatter plot. Label your scatter plot with the title and axis labels. Okay, so the independent variable, which is the x variable, and of course that's on the x-axis, relies on nothing, right? It's independent. And the y variable, so the dependent variable, which is the y variable, relies on the independent variable. Okay, then you have to choose an appropriate scale. So usually what I do is I take a look at the biggest and the smallest x and y values, and I ensure that all of the data points will fit within the number that I picked. So you always want to go with like the maximum x value or y value. Okay, and you got to plot it up to there. Your scales don't have to be the same depending on your data. Okay, then we're going to plot the x and the y coordinates, coordinate pairs as points, and then we're going to draw a line of best fit by drawing a line through the data so that the line goes with the trend, and approximately half of the data lies on either side of that line. Okay, lines of best fit can be used to interpolate and extrapolate. So interpolation is making an estimation within the range of the known data, and extrapolation is making an estimate beyond the original data. So when we say beyond, we're always thinking like forward, like more. It can also be less than. So if the data lays here, it can be more or less than. Example 1, Shannon recorded the cost to customers' restaurant bill and the amount that they left her as a tip. Okay, so follow the creating a scatter plot algorithm on the previous page to graph the data below. So let's do that first. So we have bill and then tip. So this is always going to be your x, this is always going to be your y. So this is the x-axis, this is the y-axis. What we want to do is we want to take a look, label this, but we want to take a look at the largest number in the x column and the largest number in the y column, because we know that our number needs to get up to the largest. So we need to get up to 72 on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we need to get up above 72, let's go up by 10. 10, 20, 30, 40, 50, 60, 70, 80, and we can stop there because we're now above 72. And then in the y-axis, the largest tip they got was $14. So if we count the y, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14. Actually, that's 14. We can just count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so sometimes I mark them all, sometimes I just mark maybe every other one. So let's go by twos here, just so it doesn't get too messy. Okay, so now let's plot. So when we're plotting, and it has to do with money, these decimals are really, I mean, it's going to be an approximate amount. So 25, 4. So 25 is going to be in the middle. The 15 cents is not going to make a difference. Okay, so 4. Let's graph in green. There we go. 38, 550. So 38, 550. And this is the 5, right? So it's going to be halfway up to $6 because the scale for the y-axis, for the tip axis, is smaller. We can actually pay attention to the decimals. Okay, 19 and then 250. So 19 and then 250. I'm going to round this to about $50.09. $50.09. And then 32 and 5, so just after 30, and then up 5, and then 72 and 14, so just after 70, and then 14. Okay, so now, and then we can actually, we can call this customers' bills if we want. There we go. Okay, now B, comment on whether the line of best fit goes up to the right or down to the right. So when we talk about up to the right, we talk about a line that looks like that, and then down to the right, going down. We always read graphs from left to right, just like we read a book. Okay, so if I want to draw a line of best fit, and this is going to be approximate, of course use your ruler. I don't even have a line. That's fine. Let's go like that. Here's our line of best fit. Okay, this definitely goes up to the right. So up to the right. Now, how closely clustered are the points around the line of best fit? I would say that they're very tight. Okay, so they're either lying on the line of best fit or very, very close to, like in distance away. So I'm going to say tight. Okay, what's the reliability of this data? Well, 1, 2, 3, 4, 5, 6. There's only 6 points. Only 6 data were collected, so not too reliable. I think that if you are, if you're a waitress, you probably have like maybe 10, 20 tables a day. So, okay. Using your line of best fit, estimate Shayna's tip if a customer's bill is $50. So how would we do that? I'm going to go red, okay? So if the bill is $50, what we're going to do is we're going to look on the x-axis and we're going to locate $50. And we're going to just follow this up until it hits the line of best fit. So specifically the line of best fit, not like if there's a data point here, which there's actually not a data point at 50, there's a data point at 49.66. But we don't just want to follow it up to the data point because the data point may not lie on the line. The line represents our trend, so we always want to go with our trend. Okay, so I think that she's going to get a $9 tip if the bill's 50 bucks. Okay, now if the bill is $20, let's estimate Shauna's tip again. I'm going to say 3. Okay, so if the bill's $20, I estimate 3. $3 tip. Be able to graph the following data on the grid below using the creating a scatter plot algorithm and answer the questions below. So, daylight hours on August 15th. We know that this is going to be our x, this is going to be our y. So on the x-axis, we're going to put latitude in degrees north. And on the y-axis, we're going to put length of daylight time. I'm going to put DL time. And that's measured in hours. Okay, so we need to go from 0 to 90. These are beautiful points because they increase by 10 each time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just checking that we have at least 9 because we have to go up to 90. 9 boxes here. 70, 80, and then this is 90. Okay, so we have to go from 12 to 24. Okay, so that's fine. 1, 2, 3, 4, 5, 6. We have 6 boxes here, and if you think about it, 24 is divisible by 6. So 4, 8, 12, 16, 20, 24, because it's just like we're taking the biggest number here and we're dividing it by how many boxes we have. Okay, which is 4. Now, let's actually graph. Okay, 0 and 12.1, 10 and 12.5, 20 and 12.8, 13.3, 13.8, 14.5, 15.8, 18.5, and then we have 24 and 24. Okay, so this definitely goes up to the right. Let's do the line of best fit. I would almost say that the line of best fit goes it's hard because I feel like these 2 points here are outliers. And I feel like this is the trend of the data, and then you have 80 and 90. Like very, very high outliers. So let's not include those. But you have to state it, like circle it, X it out. You have to state that you're not including it. By the way, this is called daylight hours on August 15th. Okay, how closely clustered are the points around the line of best fit? They're pretty tight, except for 2 outliers. Okay, comment on the reliability of the data. I think the length of daylight around August 15th is going to be approximately the same every year. It's probably consistent, it's probably reliable because it was satellite images. I hope that's how you spell satellite images. And like the Earth, like the seasons and daylight are the same, are generally the same each year. Okay. Using your line of best fit, estimate the length of daylight time, so that's what we're solving for, when the latitude is 55 degrees north. So, latitude is 55, we go all the way up to the line of best fit. See how there's no point, that's okay. And I'm going to go over, and it's right below 16. 16 is right at that, the grid. So let's go 15 points, almost like a 15.8. hours. Okay, and again, using your line of best fit, estimate the length of the daylight time when the latitude is 100 degrees north. Okay, so going back up here. So this is what I want to point out for this one, okay? The data stops at 90. However, because we've shown a trend, we can locate where 100 is, and I'm doing this in deep purple red, and we can follow it up to where the line of best fit would be, and then we can carry it over. So I would say 16, this would be 18 here. Let's go 19, okay? So just easily 19 hours, okay? And just to point out, this in here is interpolation, and this here is extrapolation because it's outside of the range of data.